Hello and welcome to Esri's virtual 2020 Users Conference. The topic of this session is fighting fraud, waste, and abuse with ArcGIS. I'm Patrick O'Brien. I'm a solution engineer on Esri's public safety team. And as a solution engineer, I have extensive experience using ArcGIS to combat fraud, waste, and abuse in various organizations, from federal, state, and local governments, as well as the private sector. We view these fraud, waste, and abuse workflows as law enforcement workflows. There are so many similarities in combating fraud, waste, and abuse as there is to crime analysis. That's why we use fraud, waste, and abuse workflows on our public safety team. Today, we're going to show you how we use ArcGIS to fight fraud, waste, and abuse and demonstrate some of these capabilities specifically in the healthcare field and in relation to grant management. Fraud is an ever-changing activity that presents a constant challenge. As ways to commit fraud evolve, so must the ways we combat it. Fraud, waste, and abuse also looks different from organization to organization. We have experience combating healthcare fraud, grant fraud, credit card fraud, and waste and abuse of government or private programs. With these various workflows, we have found a steel thread where we can use location technology to combat these fraudulent behaviors. First, we can fuse disparate data, being from your own organizational data, but also from other authoritative sources, such as federal, state, or local agencies, as well as the private sector. Second, we can find anomalies using GIS that we wouldn't be able to find using other types of tabular formats. We have to take into account space because everything happens somewhere. And in a spatial manner, we can see where these things aren't as they were expected. We can also recognize patterns not only in space, but also in time, the fourth dimension. And then finally, we can prioritize and investigate potential fraud using our field mobility workflows. These are going to be 4 key points in both of our workflows of fighting healthcare fraud as well as fighting grant fraud that you'll see we use in different manners. So as I mentioned, today we're going to focus on 2 specific areas that seem to be the most commonly abused programs, which are healthcare fraud and grant fraud. We will discuss how spatial analysis can assist in finding anomalies in your data that is suspect of fraudulent behavior. So we're going to use ArcGIS Pro and Insights for ArcGIS to analyze data, and then we're going to disseminate our findings using story maps in relation to healthcare fraud. We're also going to discuss how we can use ArcGIS in grant fraud and how we can monitor awarded grants and monitor their validity, as well as dispatch our field staff to investigate potential fraud, waste, and abuse using our mobile applications of Workforce for ArcGIS and Survey 123. So the first main topic we're going to cover is we're going to stay in this box of fraud in the healthcare space. And we're going to focus on the analysis of the data, as well as focus on the dissemination tools that we can convey our message and the findings of potential fraud. Within healthcare fraud, we use many different types of analysis. We use optimized routing to understand how far people are traveling to receive a certain benefit, or what is the optimal time that someone can potentially visit these specific locations. So we're going to specifically dive into these types of optimized routings that we can understand certain patterns within the data. We're also going to use cluster analysis in relation to healthcare fraud. So we're going to see areas that have higher potential opioid prescriptions. We're also going to find the outliers of where people potentially are overspending for healthcare. So we're going to use ArcGIS Pro to run optimized routings as well as cluster analysis. And then we're also going to use Insights for ArcGIS to give us a business intelligence look and feel using different types of charts and maps so we can understand relationships and find outliers using insights for ArcGIS in relation to healthcare fraud. And finally, what's going to be a steel thread through this demonstration is going to be disseminating those results using story maps. Story maps allow us to explain in a narrative fashion the results of our analysis. We've often seen story maps being used in support of certain cases, being either sent to leadership or being used in litigation. So now we're going to jump into some demonstrations centered around healthcare fraud, where I want you to understand first the analysis that's being used, and then also the way that it's presented, the dissemination method using story maps. In this first example, we're going to show you how we used Network Analyst in ArcGIS Pro to understand how far people are traveling to receive opioid prescriptions. Now we took that final analysis and put it into a story map that you see here. Now this is a story map journal that's going to explain the analysis that we performed and how we came to our conclusions. So the first thing that we did was we mapped a certain healthcare network. So we have a physician here in the center of the map, located by the heart icon, and all the beneficiaries who visited this physician for an opioid prescription. So the first step is to just map those locations. Now we can use ArcGIS to understand these networks. Now, as you can see, we have lines going from that physician to all the beneficiaries. Now these lines are just representations of the relationship between the physician and the patient, but we actually have a total number of driving time and total number of driving distance from each of these locations to the physician. Now, when understanding opioid fraud, we're not just looking at fraudulent physicians, but also fraudulent pharmacies as well. So here we're looking at all of the opioid prescriptions that were given from this one physician and where those opioid prescriptions were filled. So it's 3 separate locations: the location of the physician, the location of the pharmacy where the opioid was filled, and then the location of the patient's home. A couple questions we might want to ask are: how far are people traveling to one pharmacy? How many pharmacies are closer by to that beneficiary? And how many pharmacies did they likely pass to fill their opioid prescription? This might lead us into some fraudulent networks. So we use that same type of analysis of the optimal driving time from the beneficiary to where they filled their opioid prescription. And we can kind of already see one outlier. So at this specific pharmacy, at the corner drugstore, people were driving an average driving distance of 21 miles to fill their opioid prescription at this single pharmacy. Now that seems like an outlier, so let's keep diving in. Now the next question we want to know is how many pharmacies are likely closer to the beneficiary's home, and how many pharmacies did they likely pass to fill their opioid prescription at the corner drugstore. So let's take a look at a single patient here on Lake Erie. We create an optimal driving time. Instead of using the destination lines like we saw before, this is the actual optimal driving route from that beneficiary's home to the corner drugstore. We then buffered that by 3 miles, figuring any location within that buffer is reasonably on the way from that physician's or from that beneficiary's home to fill an opioid prescription at the corner drugstore. Also, similarly, we wanted to find the locations close to the beneficiary's home. So we created an optimal driving distance of 15 minutes away from the beneficiary's home. We then dissolved those 2 boundaries, figuring anywhere within these boundaries are likely closer to the beneficiary's home, or that they likely passed on their way to receive an opioid prescription from the corner drugstore, which allows us to select the pharmacies that intersect these locations. So for this one specific patient, A total of 7 different pharmacies were either closer to the beneficiary's home or likely passed on the way to the corner drugstore. Now that we know those certain geographic steps in order to understand the result for one beneficiary, we don't have to do that for all the beneficiaries within this network. We can put that into a model in ArcGIS Pro to automate that analysis. So then that allows us to understand, on average, how many pharmacies were likely closer to the beneficiary's home or that they likely passed when receiving an opioid prescription from the corner drugstore. The other interesting thing about this is now we know the average number of pharmacies passed for the corner drugstore. We can relate that to the surrounding pharmacies in this area to gain a better understanding is if we have an outlier. And also, since all of the analysis was put into a model, we can change the parameters of that model judging by the location of the country that we're looking in. So if we're in downtown Manhattan, we might change that from a 3-mile buffer from the optimal route to a 500-foot buffer, as well as a 5 or a 10-minute walking time from the beneficiary's home instead of a 15-minute driving time. So for this one specific analysis, we use the optimal driving time using Network Analyst in ArcGIS Pro to give us the results of how far people were traveling to a certain pharmacy. Then we used buffers and select by location to find the pharmacies that were 15 minutes or closer to the beneficiary's home and within the 3-mile buffer of the optimal driving route from the beneficiary to the pharmacy. We then put those results into the story map to where we can share with the leadership or the public the results of our findings. Similarly, in healthcare fraud, we can also use insights for ArcGIS. Here I'm looking at a very certain data set, except I'm looking at physicians, indicated by the red squares, and beneficiaries, indicated by the blue dots. Here we're trying to understand, in a subset of physicians in a certain area, if a certain physician has an abnormal opioid prescribing activity. Now we're going to assume all these physicians are of the same physician type, such as a family practice physician. Judging by this workbook, we can indicate that Dr. James Miller has an abnormal prescribing history. This physician has prescribed an exorbitant amount of opioid prescriptions compared to the other physicians in this study, which is specifically noted by this bar chart here on the bottom right, as well as the histogram, denoting the average number of prescriptions per patient that Dr. James Miller is prescribing to. Insights is a great way that allows your analyst to have the ability to do deep data discovery and drill into specific data sets to try to identify outliers and potentially fraudulent behavior. Now, the great thing about this is I've created this certain workbook to understand fraudulent behavior in the Harrisburg, Pennsylvania area, but Insights tracks my movements. So if I click the analysis view, I can see the algorithm that I took in order to create that specific analysis. If I want to perform the same analysis on a different part of the country, all I have to do is update my patients to doctors data set, and I'll have a workbook with the same look and feel to try to identify potential fraudulent behavior. The next analysis I want to showcase is the impossible day scenario. So this is how we use geospatial tools to flag suspicious billing patterns in physicians. The power of GIS here is being able to run analysis on millions and millions of claims. So out of these millions of claims, one physician, or potentially more, is fraudulently billing Medicare for patients that were never visited. With spatial analytics, we can find those outliers. So on paper, there's nothing unusual, just a map of patients and the days that they were visited. But geographic patterns begin to emerge when the points are colored based off of the visiting physician. One pattern that we notice is most physicians are visiting patients in tight clusters. However, one physician's patients are very dispersed through the region. Just seeing the pattern might not be enough to confirm fraud, but what we did is we leveraged a process called optimized routing, where we can predict the most optimal route that each physician might have taken to visit their patients on a given day. We can then calculate the time of travel plus the time of care given to find how much time that the physician could have possibly finished their working day in. As we can see here, the physician in red spent potentially over 8 hours in the car, not denoting traffic. This is quadruple the drive time of other physicians in the region. One day of strange behavior is typically not enough to generate a red flag, but it can be an isolated billing error or perhaps one very long day. However, of this analysis, when we look at the time of travel plus the time of care over multiple days, we can see that this one specific physician is potentially overcharging Medicare with their impossible days. Sometimes we see the total amount of time driven plus the total amount of time of care exceeds sometimes 18, 19, even 20 hours. So using GIS and optimized routing, we can pull out these anomalies and start to investigate these potentially fraudulent behaviors. The next analysis is using location intelligence to flag suspiciously high billings. So some people might not know they're being overcharged based off of the region that they're in. So let's take a look at an example of how we're using cluster analysis to try to find locations that are overcharging. So here we have a case study where we have 20 MRI claims submitted by various physicians across the metropolitan area in the Midwest. Adding labels to these points gives us some added insight to spot the overpriced service. But this method does not work well when dealing with hundreds of thousands or even millions of records. To look for outliers in large data sets, each point needs to be evaluated in context. ArcGIS technology can answer the questions: how does the charge compare to similar charges around it? And if the price is higher, is it statistically significant? To sort through the noise, we can implement a toolset called mapping clusters. These easy-to-use functions identify patterns and outliers to understand how the points are related to each other. Looking at the data in a spatial context, a few key facts about MRI bills can be extracted. The average MRI bill in the region is $1,500. One provider is offering a competitive price for the service, an MRI bill of $800. And another provider has been flagged for investigation as they have billed over $3,000 for an MRI. Looking at the national data set, $3,000 billing might fall below the threshold to be flagged. Approaching the problem spatially offers new insights, finding anomalies in massive data sets, and identifying a potential subject for investigation. So let's take a look at the real-world example of this and look at the entire data set. The map on the left is cost of MRIs at facilities across the United States, and the map on the right is an MRI cost prediction analysis. The map on the right takes the historic information and tries to predict if a new event were to happen, what would we expect the cost of an MRI to be. The map on the left is trying to identify outliers within this data set. The outlier that we're concerned of here are these orange locations, indicating a hospital or a location charging a high amount for an MRI in an area that statistically charges a low amount. So let's dive into here to see if we can confirm this activity. Here I have a high-low outlier, University of Pittsburgh Medical Center at St. Margaret, where they're charging $3,344 for an MRI. The hospitals in the same region, such as University of Pittsburgh McKeesport, is charging $1,692, $1,280 at Jefferson Regional, and $1,788 at St. Clair Memorial Hospital. This type of analysis can be used in many different ways and with many different types of data. to try to identify the outliers within a spatial context. This type of analysis can't be performed in a tabular format because it really relies on the spatial statistics to identify hotspots and cold spots of costs of MRIs around the country, and then finds those outliers that are statistically significant that don't match the patterns in which the full data set explains. So now that we have discussed the certain ways that we can use ArcGIS to combat fraud, waste, and abuse in the healthcare space using analysis and dissemination, let's switch gears a little bit and talk about a different type of fraudulent behavior. Next, we want to talk about grant fraud. In this section, we're going to talk about how we can use ArcGIS to monitor potential grant fraud, as well as investigate those grant fraud using our field mobility workflows. As we go through the grant fraud, I'm going to show you how we're going to actually fuse disparate data together. So looking at grants related to COVID relief, as well as the areas that are being impacted by the COVID pandemic. So we're going to fuse that data together and visualize that and monitor it through Operations Dashboard for ArcGIS. That way we can track the grants and understand why certain areas are requesting more money than others to check the validity of those grants. Next, what we're going to do is we're going to use investigative workflows to prioritize potential fraudulent behavior, dispatch our investigators using Workforce for ArcGIS, and use field data collection using Survey 123 so we can report back to headquarters of the findings of our investigations. So now we're going to jump directly into our demonstrations for grant frauds. And here I want you to really understand, how Operations Dashboard is being used to monitor our grants, and then how we're using our field mobility workflows to investigate potential fraudulent behavior. So now we're going to switch to a tabular view. Here I have a spreadsheet of BJA funding, which stands for Bureau of Justice Assistance. This is in relation to the COVID-19. Now directly in Excel, I can use ArcGIS Maps for Office to map these locations. So I've mapped these locations in two separate ways. I've mapped these as each individual request for funding as a separate point in the map, as well as aggregating all of these points to the state boundaries. So we can see the total sum of amount per state, as well as each individual location in a more detailed map. I have shared this up with my organization and put this into an operations dashboard that gives us a better viewing ability of this data. So this is the operations dashboard that gives me some total sums about the BJA funding. So currently there's a total number of 202 BJA awards that total $91.9 million. And there's 43 open awards totaling $3.8 million, and 159 awards have been awarded but not yet accepted by the locality or the state, which totals $88 million. On the right side of the screen, we can see that we have a total awarded by state. So the state of California was awarded the most. And when I click on California, it filters all of the individual awards. So I can see the awards within California that are from most to least. I've also associated this with COVID data. So I wanted to ask some questions about this data. So I'll put this into Insights for ArcGIS. So here we have the same data that I published from Excel, but instead of having it in Operations Dashboard, I put it in Insights for ArcGIS. It gives me the same data, yet Insights gives me a business intelligence view of that data, so I can do deep data discovery. This chart here, which has multiple data attributes in the same chart, is indicating the total sum of confirmed COVID cases per state in the orange bars, and the total sum of the state allocation for BJA funding as the blue line. So what's interesting here is California totaled about $93 million in total funds, yet they only have 81,000 confirmed COVID cases, whereas the state of New York has over 350,000 confirmed COVID cases, yet is only being allocated $45 million at this time. So this is just one interesting view that we can use by mashing up multiple data sets together to give us an understanding of where money is being spent and why. I also have a very similar dashboard, and this is looking at the COVID Emergency Support Fund for the state of Florida. Within the COVID Emergency Support Fund, they're trying to understand what counties within the state of Florida have been awarded allocation, which ones are currently applying for allocations, and which ones have not yet started. This gives us a broad understanding of the total number of COVID cases per county, actually, because we want to spend the most money where COVID is impacting the hardest. So on the left side of the screen, we can see the total of 44 counties out of 67 in the state of Florida have been awarded contracts. 12 counties have started, which is about $1 million still left in allocation, that have started the application process, and 11 counties in gray X's have not started yet. In the list on the right, I can also have a largest to smallest view of the counties within the state of Florida of total awarded amount, and also the confirmed COVID cases and deaths within each county. So it's not surprising that Miami-Dade County is being granted the largest awarded amount through the CESF fund, because COVID is impacting the hardest in the county of Miami-Dade. We also have lists of the counties who have not yet started, as well as the counties who have started the allocation. Now, for the counties who have started the allocation, we kind of want to take a deeper dive into why counties are asking for how much money. So we have three separate bar charts here. The top being the counties who have started the application process and the total number of confirmed cases that they have. The next is the total number of confirmed deaths of each of these counties. And then of each of these counties applying for aid, how much are they applying for? So the total allocation. Now this looks like a pretty standard relationship. We should kind of almost see a very similar relationship in each of these charts. But we do have one outlier here, where Gulf County is asking for $211,000, yet has only one confirmed COVID case at this time and 0 deaths. So that's one of the outliers that we can immediately see when mashing up our data together to try to understand where money is being spent and why. Now, the next step that I might want to do is deploy resources in the area to investigate these findings. So I can use Workforce for ArcGIS. Workforce for ArcGIS allows me to deploy my staff using an out-of-the-box application, and it gives our dispatcher the ability to assign assignments, and then our assignees, our field mobility workers, are going to be able to track the investigation of potential fraudulent cases. So I'm going to pick a random spot down here in the Keys on the island of Islamorada. And here we have the Crystal Health and Rehab Center nursing home. So I'm going to create an assignment because I'm going to just assume that we were given a tip at this specific location. So we need to send one of our dispatch workers to this location to fill out a survey. So we're going to create an assignment. So I can select my assignment type. So we can select potential fraud, waste, and abuse at the assignment. I'm going to put down the ID number of that facility, and I'm going to assign it to Patrick O'Brien. I can give this a high priority with a due date of Saturday the 20th by 10 a.m. Put in the description, enjoy Islamorada. and check for fraud. Now on the right side of my screen, you're viewing my mobile device, so I can show you exactly the process that Workforce for ArcGIS has. So I'm going to create this assignment in my dispatching view. And in Workforce, we can see that we are notified that we have one assignment that's currently added of high priority. So I'm going to click on that assignment. I can see that's down in Isla Morada. So I'm going to notify that I have started that assignment. So back in Workforce dispatching application, I can track the status of this Crystal Health and Rehab Center LLC is now in progress. Now in my mobile device, I have the ability to take a survey at an assignment, which is going to launch Survey 123. And here's where I can take down information based on the findings of my investigation. So as we can see that by inputting the facility ID, it automatically pulls the information of the facility name, the exact location of that facility, the address, city, zip, and other information that I don't necessarily need to fat finger in. This is a capability within Survey 123 that allows me to pull data based off of a unique identifier versus manually inputting in that information all the time. I can then go through all of the checks of this facility to make sure there's no fraud, waste, or abuse. And I can even add attachments, such as taking pictures at these locations. Now, once I submit my reports, these reports can feed directly back into dashboards that allow me to track my investigations, going from open investigations to investigations in review, and then finally confirmed fraud cases. Okay. So that concludes our demonstrations in relation to grant fraud. So I hope you were able to gain an understanding of how we fuse disparate data together using ArcGIS. We was able to monitor our grants using Operations Dashboard, and dispatch and investigate potential fraudulent behavior using Workforce for ArcGIS and Survey 123. So now let's take a look back at our 4 main points once again. So as we mentioned, fraud is very different from organization to organization. We cannot take our specific workflows from one organization and apply it to the other to find potential fraud, waste, and abuse. But we can use these same patterns in order to combat fraud, waste, and abuse by fusing disparate data together, by finding anomalies in space. We can recognize patterns not only in space, but also in time. And finally, being able to prioritize and investigate potential fraud using our field mobility workflows. So that concludes our session. We hope you enjoyed it, and I look forward to working with you all in the future to help your organizations utilize ArcGIS to its potential to combat fraud, waste, and abuse. Thank you very much.